Hey guys, we're going to be going over question 2 on the 2015 AP Calc AB free response question. Okay, so looking at the problem here, it says let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x, and g of x is equal to x to the 4 minus 6.5x squared plus 6x plus 2. And we have R and S as the two regions enclosed by the graphs of F and G. And we have part A, B, and C. So part A asks us to find the sum of the areas of region R and region S. So first we need to find the intersection point right here. To do that, we have to set f of x equal to g of x. And so we'll set these two functions equal to each other, and we solve for x, and we can do this in the calculator. And then we're gonna find that x equals 1.032832, and you can also find y by plugging x back into one of the functions, but that's not going to be necessary for this problem. Now we move on to finding the areas added together of R and S, and to do that we're going to have the integral from 0 to a, and a will represent 1.032832 of g of x minus f of x dx. And we do that because g of x is the function that's on top. And we're going to add that to the area of S, which is the integral from a to 2 of f of x minus g of x. So we're going to plug in all the numbers that we have and the functions we have, and when you plug it into your calculator, you'll get 0.997427 as the area for R. You'll get 1.006919 for the area of S. When you add them together, you get the answer 2.004. And the guidelines will give 1 point for the limits. So that's finding the intersection point. And we'll get 2 points for the integrand, which is the setup right here. And you get 1 point for the answer, 2.004. So in total, this part is worth 4 points. So part B is asking us about cross sections. So region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So we will be having perpendicular lines to the x-axis, which are vertical, and these are the side lengths of squares. Now remember that the area of squares is s squared. So when we're trying to find the volume from a to 2, we have to have f of x minus g of x, which represents the distance of these side lengths, squared. Side length squared. So we plug in everything that we know. So we have 1.03283 that we determined in part A, and we plug that in for A, and we plug in the functions. And the final answer that we get is 1.283. And you will be receiving 2 points for the integrand, which is this. And you'll get 1 point for the answer, 1.283. Okay, so C is asking, let H be the vertical distance between the graphs of F and G in region S. Find the rate at which H changes with respect to X when X equals 1.8. So we have region S right here, F of X, G of X, and H is the distance between F and G. So it's asking us to find the rate at which H changes with respect to X at 1.8. So we know that the end right here is 2, so we can guess that 1.8 will be around here, just for visual purposes. So we have h of x equals f of x minus g of x. It told us before. And to find the rate at which h changes, we have to find the derivative. So you do the derivative of both sides. H prime x is equal to f prime x minus g prime x. So now we have to find the derivative of f of x. So you want to go here and press differentiate, and we type in what f of x is, which is 1 plus x plus e to the x squared minus 2x. And then you have to remember to do comma x because you want to know what variable you're using, and that is your derivative. So now we want to find the derivative of g of x, so differentiate, and g of x is x to the 4 minus 6.5x squared plus 6x plus 2 comma x. And there we have our derivative. And then we plug in 1.8 into the functions that we have because we want the rate at a specific point at x equals 1.8. So once you plug everything in, you'll get the answer to be negative 3.812. And you will get 1 point for considering h prime. That is the rate at which h changes. And you'll get 1 point for the correct answer, negative 3.812. Okay, some common mistakes that we see in this FRQ is at part A, when we're trying to find the sum of the regions of R and S, what'll happen is this represents region R and this represents region S. But people will forget to switch f of x and g of x. So they'll have g of x minus f of x, and for region S, they'll have g of x minus f of x again. But what you need to know is that since this is f of x becomes on the top for region S, while g of x becomes on the bottom for region S. So part B was asking to find the volume of the solid using square cross sections perpendicular to the x-axis. Now people make mistakes on using the correct cross-section formula. Remember that square is s squared. Equilateral triangles are root 3 over 4s squared. Semicircles is pi over 8s squared. And isosceles right triangles with legs on the base is 1/2 s squared. Now there's a few more formulas out there, but it's good to know the different formulas for each shape. So part C was asking to find the rate of change of h with respect to x at x equals 1.8. So oftentimes people will set up the problem correctly. H prime of x equals f prime of x minus g prime of x. And they'll solve until they get the equation that gives you the rate of change at which h changes with respect to any x. But they'll forget to plug in 1.8. The question asked, find the rate at which h changes with respect to x when x equals 1.8. Now they'll get the point for setting the problem up and considering h prime of x, but they won't get the point for getting the answer. And in the description below, I will be linking more videos that will give help on this type of AP problem if you would like.